Hello, in this tutorial we will be studying about C++ standard library vectors. Vector is located in the header include vector, and it is inside namespace std using namespace std. So what is vector? Vector is just an array. It's a class which take care of all the details of handling arrays. In C++, in the old C++, we could, for example, create a dynamical array like this. Let's say we have let's call it array like this. Well, a like an array, and we will say new integer and the type of the elements, and let's allocate 10 elements. So this is how we can allocate elements in the old C++. 10 elements, and now we can set elements like, let's set the second item to 89, and then we can print this result A1 end line. Let's run this. And there we go, 89. The second element is 89. But in the new C++, we want to really use a vector. So to do the same thing with the vector, we will say here, we will first type vector, and it's a template, meaning that we can define what type is each element. So here we will define what is the type of each element. In this case we want integers. We could put here double. If we put double, it means that all the elements are doubles. This would mean that all the elements in the array are vectors, which would be similar to this one. Right. But let's create integers this time. So, and then space, and then we will create, let's call it b, and 10 elements. Oh, okay, if we want 10 elements, we will initialize it like this. So this one tells we are initializing. This is a class, and it's calling its construction function here, and this will tell the size of the vector. And now we can use it exactly the same way as the C array or the old C++ array, just like this. So we can say now 1 set to 89. So let's now print B instead of A, and we can see that this thing works. This thing didn't work. And why is that? What did I do wrong here? B1 is... Aha, because I have a character here. Sorry. Let's try now, because we really are creating integers here. Oh, there we go. Now we have better luck. So 89. So it works exactly the same as this one, isn't it? But the problem with this old C++ is that when we finish this, when we finish a function, we need to delete this array. So this was the way we do it back from 90s. So we say delete A. There you go. And also we normally would set this to 0, this pointer, so that we know that it's not anymore in use. So we need to remember always this one, otherwise we might get a memory leak. But nice thing with this vector is that it will automatically free the memory when the scope ends here. So here it will automatically delete all the memory. We don't need to do anything for it. It's automatic. So it's nice. We don't really want to do this thing. We might even forget to delete this, and that will cause memory leaks. So this is no. This is no. We don't want to go here. This is always what we prefer to do. We don't want to do this one if it's just not really necessary, and rarely it is. It's very rare that we need to do this one nowadays. So always when you want to create a dynamical array, just I recommend to use this one here. So let's forget now this one forever. Bye bye. You are gone. Okay. So let's now start studying about this vector, and I'm gonna go into very details, by the way, in this set of videos. I'm gonna explain very much about the vector. So if you just follow all these videos and you understand everything, well, you understand a lot, because this is an experience after many years I've been using vectors, and so I try to help to understand the main things and the important things. And the other thing is that I already opened here this site. So this is a nice site here. So this is the vector which we're gonna study, and we're gonna probably go through all these functions one by one, and I'm gonna explain them nicely. So after this you're gonna understand everything about vectors. Not everything, but 99% is hopefully. So I recommend to go to this website and check this thing here. But I try to create my own examples and explain myself as well as much as possible. Right. Okay, so this is the way to allocate the size of the memory. So now we have 10 items here, and one way we can initialize items with just the basics first. So the very basics. So we can initialize the elements straight away. We can put here 2, 1, 7, 5. And by the way, I'm talking about now C++11 or C++14 at the moment, or 17. So please, if you don't have this compiler, I recommend to go there. I'm not teaching really the old C++ anymore, because that's an ancient fossil C++, so let's not go there. So I'm teaching the latest one, so please help yourself and find this nice compiler, which is Visual Studio Community. Nice one. Latest one, 2015. So this is the way to initialize, create 4 elements in a vector and initialize each element to be 2, 1, 7, 5. So now if we print this vector, for example the third element, obviously we are gonna expecting to see 7. 7. Very good. So the third element is 7. So right. And next interesting question is that how much memory this vector, what is the memory management with the vectors? Well, it is quite intelligent, by the way. The vector is able to allocate itself quite intelligently, because we don't want to do reallocations, and I will explain it to here. Let's go a little bit back to the old C++, so you can see what is the problem with the old C++ actually. So let's say we have an array in the old C++, and let's have 4 integers like we have here. Let's try to imitate this situation, and new here. Now let's say that we want to add, and we will set the values well in the old C++. I guess we do it like this. This is 2, the first element is 2, and so on. I don't remember any better way to do this. If somebody knows, please help me. What was the best way to initialize these things? But at least it works like this. So this is the way to set all the elements. Okay. So now it's exactly the same what we have here. But let's say that we have some code here. Okay. And then the user adds a new element into array. Let's say that we're asking user, okay, what's your age? What's your this? And then we're adding the fourth age element, for example. Let's say that these are ages, and there's a new age coming, so we get the 5th age. So we need to have 5 elements now in the array, but we want to keep the original ones here. We just want to reallocate this array so that we have now 5 elements. So we want to set, let's say we want to set the fifth element, we want to set to 24. Ouch, we can't do it because this is only 4 elements. This would crash the program probably, because we have only 4 elements. We can't use the fifth element, so we need to allocate more memory here. So we need to get 5 here at this moment at least. So in the old C++, what did we do? Well, in the old C++, first we will copy the old data temporary. Okay, so we need to copy this data to a new array temporary. So we need to create some maybe B and copy all these elements there. Then we need to copy all data temporary to another array. Then we need to reallocate the array, meaning this array which we are using. Sorry, first before we do that we need to delete it actually. Sorry, to is delete the old array, because we don't want 4, we want 5, so we need to delete this old 4 size 4 memory. And then thirdly we need to reallocate the array. So copying old temporary data to another array, meaning that we probably need to create a new array here. So 4, and then we need to copy from A, we need to 1 by 1 copy stuff to B, and then we need to delete the old array, this one here. So we need to say here that delete A, and then we need to reallocate A, doing this one here, but now putting 5, and now we need to copy items 4, copy items from the temporary to the new array here. Okay, so now we're copying from the B all the elements to A, all those 4 elements, all these 4 elements to A, plus we have the extra now free, so we can do this one. Okay, as we can see, there are many steps. We need to do these 4 steps here, probably 4 steps or something like this. Anyway, it's gonna be difficult job this way. Okay, so this is not easy thing over there. Obviously we can create functions, helper functions, but anyway, this is the situation. And but with this vector, how these things works, I will take out this one now, we don't need it. So with the vector, if we, let's say we're gonna push back, well, adding a new element is simple as that. We can, for example, push back. Pushback means that it will add a new element at the end. So let's say we want to put 28 to be the next item. So just calling pushback will do this job, and the vector will automatically allocate more memory, and it will copy all these elements automatically, and it will add this 24 after this 5. So now this one, the size of this vector is now 5. But now there's an interesting situation here. This is not so simple behind the scenes, and I will now explain what happens behind the scenes. First of all, to know the size of this array, we can always say b size. Okay. So let's run this now. Obviously we are expecting the size is 5, isn't it? We just pushed back 1 element, so the size needs to be 5. That's right. That's right. But now there is a secret here. There is another memory figure behind all of these. It's called capacity. And now I'm gonna explain everything about capacity. Okay, then after this everybody knows everything about vector capacity. Yes. And By the way, many other standard library containers like strings and all this, they have very similar ways. So when we understand this one, we understand many other classes also from the standard library. Okay, so let's first of all print this capacity. So size is 5. What is the capacity? Capacity is 6. I didn't put the space, but anyway, it is 6 there. Okay, what is capacity? Capacity, it's the memory the vector actually allocated. Okay, the vector normally allocates, most of the time it allocates more memory than needed. Why? The reason is that we don't need to reallocate memory. As we remember, when I was doing this old C++ vector allocation, when we added only one element, immediately we had to reallocate to the complex thing, the 4-step thing, which is a very time-consuming step as well. It takes a lot of time. So what the vector is doing is that it's allocating a little bit free space, so that if you say pushback now, so let's do another pushback here. Okay, I will add here 64. Okay, and let's print now. Let's put here endpoint here so we can see better. So what happens if we push back another number here after? Remember, the size was 5 and the capacity was 6. So what happens if I push back again? If I add another number here, let's see what happens. Okay, happens that first we get size 5, capacity 6, then we get size 6, capacity still 6. Okay, well, that means that because the capacity is 6, that means that when we said the size was 5 here and the capacity is 6, so when we add a new element, there is one slot where there is one free slot still left. There is one free slot left. That's why when we add this one, we don't need to reallocate anything. We don't need to allocate more memory because there is one free there. So that's why we are totally fine. It's a super fast. This is a super fast operation. There is no need to allocate more memory. And let me show. I drew a picture here. Where's my picture? Where's my picture? Here is my picture. My picture is... Sorry, just a second, I will find my picture. I think if I go here, open containing folder, I will find my picture, nice picture which I created just before this lesson. I was preparing it. There it is. Okay. Okay, there is my picture. So as we can see, this is the situation. The vector, if I show here, so the vector original has 2175. So the vector has these elements here. These elements, and actually the capacity actually of this vector. Let's print the size and capacity again here. I take out. Actually, let's also take out all of the lines here. So, and only print the size and capacity after doing nothing here, after only this line. So if we run it now, so we can see that the size and capacity are both 4. So that's how the standard library. So sometimes the capacity is actually exactly the same thing. So so this time the vector decided to allocate exactly the amount of memory we needed. Okay, so sometimes capacity is the same as size. So this means that if we add one more item, the vector must reallocate memory in the hard way. But obviously, because it's a very small amount of memory, it's not going to take a long time, isn't it? It's only 5 items, so it's very fast actually to create the new memory and copy the items. It's only 5 items anyway, so maybe that's why the vector decided to do this like this. Okay. Anyway, it's not our business really to judge this what the vector is doing. The vector is doing what it wants to do, right? Okay. Anyway, so we can see that both are 4. Both are 4. So this is the situation. So in this situation we have these 4 slots here, integer slots, and the size is 4 and the capacity is 4. Now when we push back this 24 and do this one, let's run it one more time. So, oops, there was an error. No, up to date. Oh, because I have this print. Let me take out this print out from here and run it again. Okay, so this was the situation. We have size 5 and capacity is 6. So let's go now here and see the picture. So this is what happens. It copied, it created a new array first of all. This is a new array in a different memory location. So this is deleted. You can put deletion over there. This is gone, and the address is gone as well. It created a new vector here, new array, in a different memory location, and it copied these elements one by one here to the new array. And sorry, I actually added 2 in this. Let's make it exactly the same. I added number 2 here. Yeah, right. So what happened in this situation, because we just run it and we found out that the capacity is 6. So it allocated 6 elements here, but the size is the actual number of elements. So there is this one slot free, so that if we add one more element to the end, we do not need to reallocate yet. But if we add 2 elements at the end, then the vector needs to do the heavy operation and delete and copy all that stuff. So that's how it works. Now let's try a little bit more extreme situation. Let's create I mean a little bit bigger vector. Let's create a vector which has 30 elements. 30 elements, and let's push back. Let's first print what it has. I'm gonna guess it has exactly 30 now. I mean both of them are 30, capacity and I was right. Vector decided to create a array which says and allocated exactly 30 places for this vector. So the capacity is also 30. Size is 30. So what happens if we now add one element at the end? Now it's interesting to see what vector is gonna, how much memory vector is gonna allocate, extra memory I mean. And yes, it did. Look at this. The size is 31 obviously because we added one element, but the capacity is 45. So the increase is definitely 50%, isn't it? It seems to me that it adds the memory like 50%, and this might be some kind of rule actually there inside the vector class. So this is the size, this is the allocated size. So 40, it allocated 45 integers. So there are 14 integers there ready to be filled up. So if I fill up more now, obviously, let's add a couple of more items. So what is people's guess now? What happens now if I add these elements here? Does the capacity 45 need to be increased or not? Well, that's quite a simple question. Everybody knows that no. The size increases, but the capacity doesn't need to increase, as we see. Now the size is 35 and the capacity remains 45. And obviously we can still add like 9 elements, at least 9 or 10 elements, and they go super fast. There's no need to reallocate memory. Okay, I think this is now pretty clear, and so we can go to the next issue here, which is how to get access to the elements of the array. So let's have 3 elements. Oh, let's allocate 3 elements like this. 24 to 78. So we have 3 elements now. So how do we get access to elements? Well, let's call it A. Just the second element will, the third element will be, for example, like this. C out. Yeah, obviously, we already spoke about this. There you go, the third element. The other way we can get access to this element is say A at, and just put the index there. So this will return exactly the same one. But this is a slower version. The first one was a little bit faster version. Obviously there is not a big difference, but in this version the vector will check things. It will check is this index valid. So which will be an invalid index? Well, it will be -2 or greater than 2. So for example, this one will be a bad one. But this add is gonna check this element and it's gonna throw an exception in this case. If we use the other one, this one, this would crash without telling anything. This will just crash and we would not really know what happened. Because it's just doing blindly this operation. It's like a C. It's exactly like C operation, like CRI will do this. If CRI crashes, if we go over the limits, then this one also crashes. There's no difference really. But this add is gonna check the limits. So let's run this one now. Let's see what happens if we give an invalid index. And there we go. Crash, crash, crash. But obviously I was running debug mode. I pressed F5 here. So if I press break now, it says that it crashed here. Oh, it didn't say anything else. Okay. I'll try again. Break. Okay. Oh, there it goes. I pressed again F5 and there it goes. It says that invalid vector subscript. Okay. And let's see what happens if I don't do this add. I'm not actually sure what happens, to be honest with you. I haven't tested this, but I hope I'm teaching the correct things. Sorry guys, I sometimes teach wrong things. But okay, but the crash was totally different, right? So I was kind of right, isn't it? Look at this message here. There's no information here. This is the normal crash if the executable crashes, right? If I press, I can press retry anything, nothing happens. Press retry. Okay, let's try this one. Okay. Okay, we actually go here. Maybe it's because of the debugging mode here, but it's still able to go there. But let's try. Obviously, if we run release here, there would be no way that this would find it out. If I run the release here, well, it didn't crash, but it as we can see here, the value is totally. I mean, it didn't crash, but obviously this is a dangerous operation. We are going out of, and we can see that the result is some random value. It didn't crash, but this is a bit dangerous situation because we are going over the limits and we don't know what's going to happen. This could even open your CD drive or something. I don't know. But the way to handle this thing with the add is that because it will throw an exception. Let's put this one again. So with this add, we can do this try catch block. Try catch, and what are we catching then? We are catching a Okay, well, nobody remembers this, to be honest with you, so we're gonna go to the website. And this I'm just teaching how to do this thing. So here's the add function here. So you go here at the bottom and we will see the what is the exception. So it says that exception safety is strongly guaranteed. And it says that it will throw this exception here. So let's press this link and see how to use it. And let's press C11. Okay, so it will throw this kind of exception. So let's just copy this code here. This is how we can use this. Okay, and now we can, let's call it E like exception, and now we can there's 2 times. So now we can say here that cout, we can print our own error message here, for example, hey, invalid, careful with your indexes. Okay, and that's it. We don't really need to do here anything else if we don't want. But this doesn't crash. This is guaranteed that it doesn't crash the program now. And there you can see, hey, careful with your indexes. So there's no crashing here. And even if let's go to the debug, back to the debug, which crashed before. So I press now F5. If you remember, that crashed before, but now, oops, it doesn't stop because this debug mode. If I press Control F5, it doesn't. The window remains. So here we go. It says that hey, careful with your indexes. And if I do the same Control F5 without this try catch block, one more time. I don't do this. If I don't do this and run only that, Control F5, and there we go. It crashes badly, and there is no guarantee that we're gonna solve this problem like that. So, and where do we want to? So we might want to use this in a situation where we don't know if this index is correct. For example, if the user types an index on the console window, for example, if we say cin and we capture this index from the user like this, and then we will put this index here to print the corresponding value. Let's run this program now. So it will print the corresponding, so we have these 3 values here, 34, 2 and 78. So now if I want to see the first value, I will type 0 here. So it prints 34, okay. If I want to see the last value of that array, I can type here, okay, I want the 3rd element, so it will print 72. So now if obviously this code doesn't know what the user is going to type, right? So if the user types now, okay, I want to know the 45th element. So now it says, hey, be careful with your indexes. So it doesn't crash, and that's a nice thing here. So, okay. So this is the way to use it. If we are not sure that this index is valid, then we could do this way. Okay. I'm talking quite long. I need to maybe talk more shortly, but this video is becoming so long now. But the other thing is that we can copy arrays easily. Let's say that we have this array here and we want to copy that array to another array. We have it then B here. So to copy an array, well, it's very simple. We just stay like this. And in C language and in old C++, we can't do this one. We have to copy them with the for loop or something like that. But here we can do like that. Okay, so how are we going to empty this array? Because sometimes we need to empty the array. We have now 3 elements, and let's say that we want to, let's say that we have a million elements. Okay, and we don't need this array anymore. We want to immediately delete this array, or I mean the content of it. or for some other reason we need to delete the array. So how can we empty the array? A couple of ways to approach this issue. We could, before I do that, I'll put back this, I copied this, okay, so that we know the capacity and size. So currently we know that the capacity and size is 3, but let's make this a little bit more interesting. Let's put 30 elements here. So here 30 elements, like this. So if we run this, we know that the capacity is 30 and the size is 30. And let's add one element here, pushback, for example. Right, so now we have 31 elements, the size is 31. Let's put this element. Let's run this one more time, so we remember. I think the capacity was 45, yes. Capacity is 45, size is 31. So what if we want to now empty this array, that the size is 0? What can we do? Well, you could do here, you could say here that a clear. Okay, so this one makes the size to 0. So let's run this one now and see what happens. As you can see, the size is now 0. So if you do a pushback, if you add an element now at the end, there will be one element then in the array. But as we can see, the capacity didn't change. So it still has 45 slots ready to receive data. So we can add 45 elements without vector needing to do reallocation. So clear doesn't really empty the space. It doesn't delete the memory. And think about the situation where you have 1 million elements, it will leave them there. So clear doesn't free the memory. It's very important to understand. It doesn't free the memory. So in some situation it can be a bad thing for the programmer, but it does put the size to 0. So if I now push back after this clear, if I push back one element, for example this one, and I'm predicting that the size is now 1, and there it is, size is 1, and there we go. So obviously the question is now that how can we really get rid of this 45 slot? We want to delete this, and if it's million slot, I mean it takes a lot of memory, RAM memory, we want to delete this. Well, we could try the next try here. Let's do the next try. The clear didn't help. It kind of halfly helped, and sometimes it is actually best thing to do to clear, by the way. But another way we could try is we could say a string the fit. Okay, there's another function in C++ vector class which is called string to fit. So with this function you are telling the vector that I'm asking you to make it size 1, because okay, size is 1 is now if you remember, the size is 1 and the capacity is 45. So if you want to get rid of the extra space so that the capacity is also 1 and the size is 1 after this, you could try this one. But the problem is that the string to fit function it's not a forcing command. You're just telling the vector that okay, I'm asking and hoping you are doing it. But then the vector might say that okay, I'm only gonna do halfway through. I'm only gonna delete 20 of those, and I will leave 20. Or it could say that okay, I will go so close. I will set the capacity to 3. Or many times I think it will do what you asked, but it's not guaranteed to do exactly that it will delete all the memory. But in most of the cases I think it does. And you might think that what's the benefit of this? Well, I don't know, but that's how it works. So if you don't 100% surely need that the memory is freed, but you just want to ask the vector to do what is best. This is what you can call. So let's see what happens now. As we can see, in this case the vector decided to follow what you said. It did shrink the size as well. It deleted the extra memory. So capacity is now 1. Okay. But as I said many times, I keep repeating myself because that's who I am. I repeat things. In another case it might not do that. So this is not guaranteed to do that. So what if you want to guaranteed freeing of memory? The way to do it is that, unfortunately, there is no function in vector which does that. And I wonder why it's like that. But the way to do is that we will create a temporary new object here. Let's call it temporary, like temporary temp. And we will copy first to this temporary array. We will copy this object which we want to reduce the size. What this does now is that when the vector is doing this copy, it will set the capacity and the size exactly the same. That's guaranteed to work. So if I sorry, if I now print this temporary size and capacity, it will be 1. As we can see, when we make a copy of a vector, it doesn't keep the capacity like we can see here. The capacity of A was 45, but after this call, when we copy A, the temporary object, only the size remains the same, and it will allocate exactly the amount of size memory. And obviously, because we wanted to really change A, so now we want to copy this copy this temporary back to A. So now A has exactly these old elements. It has this element 223, and its capacity is 1 and size is 1. And let's just see one more time this one. And there we go. There we go. Just a second. Sorry, just a second. See. Push back. A is temporary. Okay. Just a second. Okay. If I print this temporary, okay, I did a mistake here. We can't make a copy of it. I'll try it again. Let's one more time print the temporary. Okay, so temporary has 1 1 here. So what we can do here now is that we can move this temporary to A. That will guarantee to work, because moving what we are doing, if you are moving object to another object, what it does, it just copies the pointers. It doesn't deal anything with the memory. It just transfers the pointers. It swaps the pointers. It kind of moves the pointers. So we could say here that std move. We are moving this temporary to A. So and now we get 0 0. So I'm just checking now what is wrong with this. A is Oh, sorry, there's temporary here. I left the temporary. Yeah, as you can see, the temporary is not 0, 0 because we moved it. Temporary, we can't use any more temporary because it's moved. So I was printing the wrong one. So now I'm printing the A here. So okay, there you go. So if we are moving the temporary to A, it will be exactly the same as the temporary, because moving makes all the things in the other object exactly the same. Copying, as we can see, this copy doesn't do it necessarily, because the copy, if we are doing copy, the vector might only copy the elements. It doesn't necessarily touch the memory itself. It doesn't do the allocation stuff necessarily. It doesn't copy the size of the memory allocations and stuff like that. And as we can see, so this works with the move, but it doesn't work with the copy. Yeah, it doesn't work with the copy, so it needs to be swapped with the temporary. So that's the way to do it. Okay, this is the first video, and I will continue doing more videos, and we will start going through these things one by one, all of these things, and we're gonna master this vector. Okay, thank you for watching.